So in algebra review number 5, we are going to be able to simplify radicals by identifying perfect square factors. When we refer to radicals in this lesson, we're going to be talking about square roots. And we know it's a square root when there is no number up in the upper left side here. We just assume that there is a 2 there. But radicals are also cube roots and fourth roots and so on. But we are going to deal just with square roots in this lesson. So you were asked to write your perfect squares up through 15. So you should, a perfect square is when two numbers are multiplied together, and the answer is the perfect square. So 1 times 1 is 1. That's not going to help us today, though. 2 times 2 is 4, and so on. $13 squared is 169. Oh, I forgot one. Sorry. Let's do 12 squared first. So that's 144. 13 squared is 169, and I remember that 14 squared is 196 just by flipping the numbers. And then 15 squared is 225. Factors. Factors are two numbers multiplied together to get a number, a product. So you were asked to write those, and we want to think about the factor squares. The factor pairs in this. So a factor pair is 1 and 320. That's because 1 times 320 is 320. 2 and 160. That's because 2 times 160 is 320. Oops, that's not a 20. There we go. And we can keep going. 3 doesn't go into 320. And if you don't know these factors off the top of your head, that's okay. Use your calculator. Take your calculator. 320. Divide it by 2. Divide it by 3. 320 divided by 4. 320 divided by 5. To get your factors. These are big numbers. And you might not know them all off the top of your head, and that is okay. So these are the numbers you should have. And when we talk about a pair is the top and the bottom here. So let's look at this and identify our perfect squares. And if you don't recognize your perfect squares, you have them on just above this on your paper. So we know that 4 is a perfect square, that 64 is a perfect square, and 16 is a perfect square. So today, when we're working on these problems, we want to identify and use pairs that have a perfect square. Because our goal is to simplify the radicals, and we can only do that when a perfect square is inside that radical. So the square root of 16 is 4. The square root of 4 is 2. The square root of 64 is 8. Those are the numbers that help us simplify radicals. So we're going to simplify radicals by making sure that they're in the simplest form. And that is true when there's no radicals have perfect square factors other than 1. No radicals contain fractions, meaning we can't have anything that looks like this. And no radicals appear in the denominator. So things that look like this. And we're not going to really talk too much about that today, but it will affect us later on in the school year. So the product property says that if I have two numbers inside of a radical, A and B, that I can separate them into two separate radicals, A times the radical of B. So let's look at ones with numbers. So square root of 3 times 7, that can be separated into the square root of 3 times the square root of 7. The square root of 3 times 7, when numbers are inside the radical, we can combine them to be the square root of 21. But what we need to look for today are factors of numbers. So factors of 21 are 1 and 21, 3 and 7, So we want to separate those numbers into their factors. And then we're going to look for numbers that are perfect squares. Neither 3 nor 7 are a perfect square, so actually the square root of 21 is in the most simplified form. On the same side, there's the quotient property, and the quotient property says the same thing, that if you have a 12 divided by 5 inside a square root, that you can separate that into two radicals separated by that fraction bar, which is our division symbol. And looking at that, we can decide whether or not there are factors that are perfect squares. And there is in 12, there is not in 5. But let's move on, and we might use this at some point. So, simplifying factors, radicals. We want to look for factors that are perfect squares. So the easiest way to do this, okay, is write out your factors. Take your calculator and write out your factors. If you're trying to do it and you don't know your factors, you're going to struggle with this. So 1 and 50, 2 and 25, 5 and 10. Those are the factors of 50. In this list, which number is the perfect square? Look at your list on the front page. 25 is the perfect square. So we're going to use the factor pair 2 and 25. So 50 is 25 times 2. Now, because of the product property, I can split that up into the square root of 25 and the square root of 2. And going back, that 25 is our perfect square. Those are the numbers that we can take the square root of. So if we take the square root of 25, we get 5. Put it on your calculator. You'll see there's no square root symbol around that anymore. The square root of 25 is 5 times, I can't take the square root of 2 because it's not a perfect square. I'm going to get a decimal. We only want whole numbers when we take the square roots. So we leave it as the square root of 2. So 5 times the square root of 2 is the most simplified form of the square root of 50. When we have a number on the outside, that just means this is 7 times the square root of 27. So we're not going to deal with that number on the outside. We're just going to leave it there for a minute and take care of it in the end. So let's write our factors of 27. 1 and 27, 3 and 9. Which number is the perfect square? 9. So this is the factor pair we're going to use. So we still have that number on the outside. But now we can separate that 27 into the square root of 9 times 3. I can continue to separate that into the square root of 9 times the square root of 3. 9 is the perfect square. So now we're just doing order of operations. 7 stays times the square root of 9 is 3. Do it on your calculator if you're not sure. And the square root of 3 stays the square root of 3 because 3 is not a perfect square. So now we can combine these numbers on the outside. That's 21 times the square root of 3. So our most simplified form of 7 times the square root of 27 is 21 times the square root of 3. Here's one where there's a quotient on the inside. That can be separated up into the square root of 40 divided by the square root of 36. Before you go any further, take a look at those numbers. Are either of those numbers a perfect square? Yes, 36. So because it's a perfect square, I can take the square root of it. The square root of 36 is 6. And then on top, I have the square root of 40. So now, I'm going to move down here just so I have a little bit more room. Now we just have to deal with that square root of 40. So let's write our factors that are perfect squares. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Of this list, which number is a perfect square? 4. So we're going to use that factor pair. So I can separate that into the square root of 4 times 10, and I still have that 6 in the denominator. I can split up that perfect, that square root. 6 is still in the denominator. 4 is my perfect square. So I have the square root of 4 is 2 times 10 is not a perfect square, so I leave it that way. I have to leave it in the square root, and 6 is in the denominator. But if we look at this, we can see, we can separate this out into 2 over 6 times the square root of 10. And 2 over 6 can be simplified. We need to recognize that we can simplify fractions. So 2 over 6 can be simplified by dividing it by 2 over 2 to get 1 over 3. So 1/3 times the square root of 10. And I can put the square root of 10 over 1 so that I can multiply my fractions to get the square root of 10 over 3. That's my most simplified form. Now, let's go back and look at 320. We've written down those factor pairs already, and we identified 3 that have a perfect square. 5 and 64, 16 and 20, and 4 and 80. Those were our perfect squares. So, we can use any one of these factor pairs. The hint that I'm going to give you is which perfect square is the largest. So of 4, 16, and 64, which number is the bigger number? 64. So let's use that factor pair. So I can separate 320 into 64 times 5. I can keep splitting that up. And now 64 is my perfect square. So I take the square root of that, which is 8 times 5, square root of 5. This is my most simplified version. Now, if you don't take the largest perfect square, say you use the square root, say you use 16 and 20. So the square root of 320, I can use that. 16 is my perfect square. So 16, because that's a perfect square, becomes 4 times square root of 20. Now, I'm not finished because 20 has factors that are perfect squares. What are my factors of 20? 1 and 20, 2 and 10, 4 and 5. 4 is a perfect square. So I can simplify this even more. So 4 on the outside times on the inside, I have the square root of 4 times 5. 4 is my perfect square. I still have 4 on the outside. Now I'm taking the square root of this perfect square. The square root of 4 is 2. And on the inside, I still have 5. Now I can combine these right here using multiplication, and I get 8 square roots of 5, which is the same answer that I have above. I just did multiple steps.